the strong name. So using strong name, we can protect here the versions. So now we made library. This library, I want to now, for this library, I want to provide a strong name. So in such case, I go to build here. Just I come to configuration manager. It's not available here. I just come to string library properties. Come to this here. You have one of the tabs here, an application tab, build events, debug, resources, services, settings, reference paths, signing. You can come to signing here. In the signing, you can take like this. You can go with the sign the assembly. You can put here sign the assembly. Choose a strong name key file. You can create a new strong name file here. Key file name you can provide. Some key file name you can be using here. Put it as my key file. You can put some name like this. So protect my key file with a password. You can provide. You can protect with password, or you need not protect it. So uncheck this. Just click on OK. Okay, this is what exactly my key file.snk. It is called as strong name key. Okay, so when we use here delay sign in only, in such cases you cannot run under debug mode. So under debug mode you cannot be running. So therefore here don't do with the delay sign in. So like this, what we are going to do? We are going to create a strong name for this. Strong name file is what here? My key file.snk. Some key file gets created for us now in this. Go to build. In the build, what you do? You can start building this. We have taken configuration as here. The configuration is what exactly? This is in the release mode we are building it. If you come to this build, here under configuration manager, we have taken it as release active configuration. So here we are going to be compiling it. We compile here. So go to build here, then say rebuild solution. So here it is actually built. Now this one we can be moving into global assembly cache. GAC util, with the help of that now we can put into the global assembly cache. For that purpose we have to use gacutil.exe. There is a file called as gacutil.exe. So with the help of that we can put in the global assembly cache. Global assembly cache contains number of methods. We have so many methods in that, so many classes already defined with the .NET framework. So those classes or those libraries are globally available for all applications. But yesterday we made this string library and we were using only with the string some string manipulation. With that only we were using. So that was basically a private library. Now we can make it a public library. That means for all applications it can be available. String library can be available with all applications when you move into global assembly cache. Okay, so global assembly cache basically it contains so much collection of libraries. So those libraries are available for all applications. But when you take a private library, it is not available with all applications. It is available only with a registered application. In whatever application you want to use, with that application, the library has to be added as reference, then it's going to be working. So automatically it will not be available in private library. But when you take a public library, but how to make a public library? When we move into global assembly cache, it can be private public library. When you make a library public, in every application you can use it. But that is going to be only in this current machine. If you take some other machine, there publicly it's not available. So there also if you install, in such cases it will be available. But in this current system, it is going to be available with all the applications. If you put into global assembly cache. Otherwise, it was working only with the application where we have registered. So don't save this. Now let me show you with what exactly we added it. You just come to this file and recent projects and solutions. In this string extension methods, we have this class. In this particular program, string extension methods application, we added the reference. Here is nothing but a reference we added, string library we added. Because of that, the library is available here. Otherwise, this library will not be available for us here. So since we added it, string library, right now it's a private library. Privately, you must be adding with the concerned application. So automatically, it will not be available with the new applications. But when you move into global assembly cache, at that time, it will be available. So when we move into global assembly cache, at that time, it is available with all applications. Right now, we added it in the private manner. So right now, it is what string library is a private library only. Since we haven't kept it in the .NET Framework global assembly cache, therefore it's not available for all the applications. Only in this application it's available. Reason we referred it here. We are referencing from a DLL, so it's available here. Globally, simply it's not available. When you click on this here, add reference, go to this add reference. Here you can find so many. You can see here so many assemblies. All these are nothing but they are part of the global assembly cache. These are available with the global assembly cache. They have been already created and kept for us. These we can use in every application. Similarly, new things also, extensions there. So these are also available globally. Everywhere you can use these things. Okay, but here whatever we added is nothing but a private library and private assembly we added to this. But these are what exactly? Shared assemblies. These can be called as here shared assemblies. Okay, so these can be used by more than one application because they are part of the global assembly cache. But the string library is not part of global assembly cache. Therefore, for every application automatically it's not available. If you want to use it, privately you have to be referring it. From where we refer? From the disk we have to refer. In the disk, in whatever folder you have that library, so from there you must be referring it. So like this you have here shared as well as private libraries. So shared library as well as private library. First of all, library is nothing but code component. It contains some useful code, but they cannot be running on their own. They cannot be existing independently because they don't have any specific functionality. They provide generic functionality. So those libraries we must be using in our applications to meet requirements of the application. So therefore, first we build libraries, then we can make a repository of libraries. If you want to make the library available for all the applications, you have to register with the GAC. Otherwise, you can be making it a private library. Yes, Mr. Vincent? Hello? Vincent, you are saying something? Okay. Yeah. So, this is the basic difference between a private as well as public assemblies or shared assemblies. Public assembly and shared assembly are same. Private assembly is something like the string library which we created. By default, every library is going to be private library, but you can make it public with the help of the GAC util. Global Assembly Cache utility tool. With the help of that, we can make a library, public library. We can move into Global Assembly Cache. Now let us try to move into Global Assembly Cache, the concerned library. So for that purpose, we require here .NET command prompt. In the .NET also we have a developer command prompt. We need to go to .NET developer command prompt. For that, here I use Microsoft Visual Studio 2012. So developer tools are part of the enterprise, professional or standard. If you take Express Edition, you cannot find them. When you work with Express Editions, you cannot get only with the enterprise, only with the Ultimate Edition, professional or standard, with that they are available. Come to this, then here it is Visual Studio Tools. We click on this here, like a administrator, we have to start it. We require here administrator privileges. When you want to add a assembly, so at the time you must be administrator. Like an administrator, you must be signing in here. So get here, start as an administrator. Then here, let us try to run the GSE util. So this is here, just type GSE util, what it says, see here. It's going to show you so many options for us, something like help it is providing for us. We can install with the GSE util in this way. We can put here GSE util followed by I meaning is here install. You can be installing the assembly with the GSE, Global Assembly Cache. You can be just, installing with the help of the I. When you say IL, one or more than one file also, you can be installing with the help of the Global Assembly Cache. With the help of you can be uninstalling. So, like this you can be registering it. So let us try to register this one. But where is the DLL for us? We need to go to the concerned folder. The folder is this is the folder. In this folder, we have here string library. This is the string library. In this, in the release folder, we have it. It is here. Yes, I'll explain. Okay. So in this is what string library.dll. In the case of string library.dll, at what time exactly this is created? See here. This was created yesterday but modified some time before. Today itself, this has been actually modified. So giving like this. Now try to register this one. String library.dll. Let us try to register here. Let us come to the concerned folder. The folder is cd, then so now let us try to install this string library.dll. Even for this we created a strong name. We created a strong name even for this. Now try to do this. GSE util followed by /I we put the next thing string library .dll. What happened now? It shows assembly successfully added to the cache. You are getting this message. Yesterday we could not get, but today we are getting it. Assembly successfully added to the cache. Yesterday it was saying it could not install. Reason, strong name is required. Today with the signing we created a strong name. So with that what happened? Now this could be added to the global assembly cache. We could add with the global assembly cache here. We add it to global assembly cache. So now it should be available with all applications. By default, it should be available. Let us explore whether that is added or not, it's available or not. Let us see here. Okay. Let me start here some new application. It's a new project. So this is again console application. Test for global assembly catch. This is the name of the new project. We are trying to make it. So come to the references. Then here click on add reference. The name was string library. Let us see in this. So it is not available here for us. Go with the extensions. ST. Okay. What is the given solution? Under framework, this one is for us string library. Add reference in this. So it is setting actually .NET framework. Okay, 4.5. Probably we need to restart computer. Once we restart, it will be available for us. Messaging, numerics, system.numerics is available like this. It is added. Speech you have here. Okay, it got registered successfully. It says all its assembly successfully added to the cache. It's getting added here. So we need to restart system. Okay, it should be restarted, then it is available. Okay, this is Team Foundation BSA 4. Okay, so do one thing, just go to C drive. In the C drive, the Windows, Microsoft .NET, this is assembly. It is adding, string library is getting added. You can see here. I think you are seeing this string library is added here, version 4.0. So it is now added here. We are getting here in this area, the string library is getting added. So whatever libraries you make, they are going to be coming in the Microsoft .NET assembly. So under assembly, GAC MSIL, it's available for us. You can look at this. So whenever you do with the GAC util, it comes into this part. You can look at this here. String library is available for us here. So you can find here the string library, and when you look at this version 4.0_1, it is available like this. String library is available for us. This way we can have it. So it is added now for us string library. It is giving you some version information. Let us make one more version of the string library and try to once again put into the concerned global assembly cache. What happens? See, that's one version. Let us try to put one more version of it. So close solution, this one. Try to add here. Once again the same file we open. String library once again we open. So this time we take the signing. So sign the assembly. Here we try to put a different file name this time. mykeyfile.snk we had here. A new file name we set this time. So this is mykeyfile1. Try to make. So we don't use any password. Like this we can be making it now. This is the second file we are trying to make in this. We have two files. One is mykeyfile.snk. Second thing is mykeyfile1.snk. Like this we have here. Another file we are going to make here. Now come to the code here. In the code, let us add a new method in the string extensions. We add in the string extensions a new method. The method must be containing here. So we try to find in this number of letters in the given string or number of words in the given string. Let us try to find out. So same thing we take here. Public static string, public static ILT, here see find word count. So how many words are in this? Let us try to find here. Then int n words equal to initially 0 we put. After that we find how many words are in that, then we return n words. Here we take this way, then with the help of we try to split str.split here. We have a split method. With the help of that we can be splitting into number of words here. Split, then here we can use a single space. We split into number of words this, it gives you words here. Here we use for each loop. For each str in words. Okay. Condition you take here. Condition we take here. If str dot trim dot length same name, that's fine. Okay, length greater than 0. In such cases we can count here n words plus plus. So what happens with this? We retrieve one by one string. If it is the length of it is greater than 0, in such cases we increment the n words. Like this we are trying to make one more library here. So it's another version of the same library, but the earlier version contained only one method that contained only one method, two proper case, but here we are adding one more method. It is going to be here. So to find word count, how many words are in that, we are trying to find here. So otherwise word count only we suggest. Word count, this can be counting the words here, or count words also we can say this. Some meaningful names if we give, it's better. Count words. This can be counting the words in the given sentence. So here, let us try to build it. Now in the global assembly catch, what happens for us? We have a string library. This is containing here one version. One version is available for us. Now this time we build it and we have to move into global assembly catch. Now what happens? See in this. Go to this, then go with the build solution. Solution is built here for us. Solution is built once again. Let's try to do with this. Assembly successfully added to the catch, it is saying here. Now see, you can find the second version. Are you seeing second version here? The first version is this, second version. This is first version, this is second version. So one more version has been added to the existing code. Mohammed, are you seeing this?
Yeah, I'm seeing it.
So one more version has been added. There is no problem with the versions. See, you can add more methods. You can be creating one more library and you can be adding like this. So this way you have advantages with the number of versions. And in the runtime, whatever version you would like to choose, you can choose. With that you can make it working. So, but some meaningful names you have to give. Something like version 1, version 2, version 3. If you put in such cases, cannot be very difficult. So here it's creating automatically for us. Because this is just an example, simple examples we are trying to see. But in reality, when you develop application, definitely it can be a little bit complex. So like this here, we created second version, we kept in the global assembly catch. We can see that with the GAC_MSIL, in the global assembly catch, you can find those versions. Now any application can use these methods. Sandeep, are you seeing this?
Yeah.
So like this, we got here two versions. So now this is what these are called as here public or shared assemblies. These are called as here shared assemblies. This assembly can be used by any application. But yesterday what happened? We created assembly and the assembly could be used by whatever application is registering that assembly. But now in this case, suppose you are interested in using your new application without doing any kind of reference there. So from your application itself globally you can access. So whether such method is existing or not, where DLL is, you need not bother about that because they are kept now in the global assembly catch. So globally in any application you can use this method now. So like this you can make your library and you can put in the global assembly catch. Therefore others also can use this library. But this is going to be applicable only in the current system. Okay. Suppose somebody has to use these methods, they have to install in their machine also. They must be installing in their machine. Then in such cases, it can be working. So we are signing it with the help of the strong name. Then how many versions you want to make, that many versions you can make, and you can move into the global assembly catch without uninstalling the previous version. Normally with the Windows, if you have already existing one version, so you need to unregister, then you have to register one more version. But here what is happening? N number of versions you can make, you can install. There is no problem with that. Mansoor? Understood this?
Yes, yeah, I got it. Yeah, it's same concept. Yeah, I got it. Yeah.
Vincent, you understood this point here? Now this you can think as FCL. It's framework class library. Like that you can be thinking it. You made library and you make part of the framework now. Now it's part of the framework. So within the same system anywhere you can use this one. Base class library, it contains the data types which are available with the system namespace normally. That's called as base class library. So the types of data, then similarly the string data, so they are available with the system. Whatever are available with the system normally they can be called as base class library, and FCL are going to be the rest of the libraries like system.txt you have, system.io you have, system.data, system.data.sql client. They can be called as normally FCL, framework class library. So BCL is very basic, like data types, the common console. So all of the command are actually base class library. So FCL is here framework class library, all other libraries like system.io, system.net, system.say, data, system.text. So all these commands are actually the FCL, framework class library. So that is the class library available with the framework is called as framework class library. BCL is it's part of the framework. So it is nothing but actually system. By default, they are available to you. That can be called as BCL. There you can find data types. Mostly you find data types. An operation on those things you find with the BCL. So this is basically called as creating here different libraries and signing them with a strong name, then followed by putting into global assembly cache. To make it available with all applications, you need to restart machine. When you restart, you can make use of this particular thing. So try to experiment like this, try to read more and more on the global assembly cache. What problems you can face with them also, you try to explore. Always try to troubleshoot first, then try to do some development kind of thing. You develop initially, but then try to troubleshoot it. Troubleshooting is going to be very, very important because a small mistake, minor negligence also can be creating sometimes big trouble. So under what conditions it is failing. So if you can track, if you can trace such things, then definitely your code can be better code. So writing some code, making it error free, making it bug free, maybe a little bit easy. But under all conditions, whether it's working or not, thoroughly testing is also required. So as developers, if you can test to some extent, then definitely it can be a better solution. Otherwise, you have to always depend on the input of the testers. So therefore, if you can try to understand how internally it's working, then where it can fail, if you can if you can predict that, then definitely you can write better code. If you can visualize where it can be failing, where it can be succeeding. So you should be imagining that. Then if you can imagine and if you provide solution, then definitely the code is going to be lasting for a longer period of time. So therefore, write code, then try to test in different ways. You try to test it in the intelligent fashion. You have to test it. So then, you can give them a neat library. So like this, try to create your own libraries. Try to put into global assembly cache. Then practice with that. Okay. So today, further we are going to see some more features of the object-oriented programming, particularly with the classes. So with classes, some more features we look into. Something like here, get and set. So get and set you can use in such a manner, they can be automatically initializing the fields. With get and set, you can automatically initialize the fields. Fields can be initialized with the help of the get and set automatically. So using get and set, you can be automatically initializing without declaring explicitly the fields. If you take point, in the case of point, what we have done, we created x coordinate, we created y coordinate, we created radius. Then after that, what we were doing, we were actually using get and set. In the get module, write return x. In the case of set, you write x equal to value. Like that we are writing. But here with the help of get and set, automatically you can initialize the fields also. Fields automatically can be initialized. This feature is available from 3.5 onwards. With the .NET version 3.5 onwards, automatically fields can be initialized here. You don't declare any field, still you can initialize. So internally they can be getting initialized. That is somewhat advanced feature. I haven't shown you in the beginning, because what are fields, how to initialize them, you have to know. Now I can show you that advanced feature. In such cases, without declaring any fields, you can be initializing them with the help of the get and set. Get and set are what exactly? Property methods. We are going to see that feature, and one more thing is we are going to look into delegate. A delegate is something like a pointer to a method. So it's something like pointer to method. A method you can refer with the help of the delegate. I show you even what is delegate, how to work with that. Okay, now here what exactly it is. First of all, I am going to show you the classes with get and set here. So already we have written few classes. There we were using get and set. But in such cases, what you write? Get, within the curly braces you write return the x coordinate or y coordinate or radius. In the case of circle, we have written like that. Similarly with the cylinder, you have written get followed by return length. So in that manner we have written. But here what we do, we don't declare any fields. Without declaring any field, still we can use here get and set. They can be automatically initializing the required variables for us. Required fields will be initialized with the help of get and set. So that is called as automatic initialization. So C# is intelligent enough to create automatically the required fields for us. Using property methods, we can be accessing them. So let us create one such application now. It is a new project, console application. Here it is auto initializer of class members. So automatic initialization of class members, we take this way here. Here I just want to define some another class within the same file. When you take one physical file, it can contain multiple classes definitions. We need not limit always to only one class. You can write as many classes as possible in the same file. Physically file name is what for us here? The file name is going to be here program.cs. This is the file name. In this one program is here class program, which contains main method, which is giving you starting point of the application. But here I can be defining other class also. Here I write class followed by, just try to define the class, put the class name here. Class name is something like, here again I use point. For simplicity I am using this class point it is. Then here inside this I can be referring this way. I don't use any fields this time. In the previous example, when you created point, you use private int x, private int y. Now I don't use any such thing. I don't use any private int x, private int y. Just I write like this. Here I write public, then int followed by x. I just put like this. And inside this, I can just write here get semicolon set like this. I can write. Only this much I can be writing in this. I can just write public int x, get semicolon, set semicolon. So automatically it is going to initialize the value for x. X value can be initialized with this. So x equal to, when you put something, it is going to be initializing the field for us automatically. Internally it can be managing it. We don't know its name. Using the property method, we can access it. So internal state is getting created automatically for us with the help of this property method here. Similarly, I can put like this public int y, here it is. So this is going to be automatically initializing for us the required y coordinate also. Get here semicolon, set semicolon, you put like this. So x will be getting initialized here, y also will be getting initialized. X is what? It's a property method, y is a property method here. So using x, normally what we do in the previous example, where you have taken point class, we declared a private field called as x coordinate, y coordinate, radius. With the help of the x coordinate, we assign x equal to value, and in the case of get method, you write return x coordinate. In the case of y coordinate, what we do? We write set y equal to value, and in the case of get, we write return y. So like that we have explicitly written, but now we don't write anything like that explicitly. What we do, we just declare the methods, property methods x and y like this. We have just declared x and y, then with the help of this we can be straight away assigning it. So like this, these can be automatically initialized for us. Automatic initialization of fields is possible with this kind of mechanism. So what we do here, just we declare the property methods. With the help of this internally, automatically, it can be creating required fields for us. It can create required fields for us. So this is called as here automatic initialization of the fields of the given class. When you take class, you have different types of members in that. First thing is the field, second thing is what method, then constructors are available. So normally you have fields as well as methods. With the help of methods, you can be manipulating the data which is available in the field. Okay, and apart from method, we have one more feature called as property methods. With the help of that, we can assign value, we can retrieve value. Those we can do. Apart from that, we cannot write any other code. Now in this, you just write set as well as get. You cannot put any other code inside this now. We can write get semicolon, set semicolon. In the case of public int y, get semicolon, set semicolon. So with this what happens? You can retrieve a field value as well as you can assign a field value using the interfaces here x and y. So using x property method and y property method, here we can be assigning as well as retrieving data. This is called as here automatic initialization. If you compare with previous example, what you had there, x, in the case of this public int x coordinate, inside that you write set, within that x equal to value. Similarly, in the case of get, return x, we have written like that. But now what is happening in this? We don't write any such mechanism. Once again I show you the class which we have written. Let's come to Manasa folder. Here you can see with the oops you can find it. Okay. Here we have geometry. I open this with the notepad. I open this. So whenever not this. Okay. Where it is then we created. We created so many things like geometry, I think. Geometry with classes. So here this is geometry. Open with notepad. In this, whenever we come to this x coordinate, how it is written, see. Public int x coordinate, set x equal to value, get here return x, like this we have written. I just take this method, try to put in this. I'm trying to put here in this. So here, what is the difference between these two? Public int x, get and set we have written. But here what I have written, public int x coordinate, set x equal to value, get return x. I am not declaring any variables like x and y within the class. If you look at this code, first of all we defined here x and y somewhere on the top. We declared here private int x, private int y, private int radius. Like this we have defined. But here we don't define any such thing. Class point we have taken, we don't define any x and y coordinate. Still you can be assigning here the x value as well as y value with the help of this auto initializers here. Automatically fields can be initialized. This is a feature you can find from 3.5 onwards. .NET Framework 3.5 onwards, we are finding this feature. The class name is called here point, then public int x, public int y we have taken. We have in this get and set methods. Using get, you can be retrieving a value, and using set, you can be assigning a value. So automatically here, the fields are getting initialized. X coordinate, y coordinate, they are getting initialized with the help of the public int x and public int y. So internally, automatically it can create the required field for us, but we don't know what is the name of it. We don't know its name. So automatically the program, the .NET framework can create for us required fields in this class. So using the property method x and using property method y, you can be accessing the internal data. So x is what? It's a property method. Y is a property method. Using x coordinate, we can assign value, and using y coordinate also, we can assign value. In the same way, you can be retrieving value from the x as well as from the Y with the help of the property methods here. So this is called as here automatic initialization. The fields are getting automatically initialized for us. This feature you find with the .NET framework. So 3.5 onwards, this feature is available. So these are going to be working like true getters and setters. Apart from getting and setting, other things you cannot do here. Truly, you can assign a value, you can be returning a value with the help of this get and set. So like this, these are going to be working for us. So automatically fields are getting initialized here when compared with this example. So in this example, what we have, first of all, we declared x variable, y variable, then we assign here. Using this property method, we can be assigning x coordinate you take, set x equal to value, and then get return x. Explicitly you need to write here, but when you come to this, we don't require anything like that. Public int x, get semicolon, set semicolon, public int y here, get semicolon, set semicolon. So like this, automatically you can be initializing these. Getting here my point? Mansoor, understood the difference between?
Yes. Sorry, I just. Yes, I got it, but that's okay. But what value in the x?
Whatever you
In this
assign.
case,
See, whatever
from
you
the previous
assign.
example. Previous example, I got it.
Yes. No. Here, whatever you assign, it comes in that. For example, you create like this point followed by in this object p equal to, you put here new point. When you call constructor like this, probably you have to write here in the constructor, you should be writing the values there. You can put like this. See, this is what public, then this is point, you can put this way. In the constructor, define it. What values you want to assign in this? You can assign like this. X equal to 0, you can put, y equal to, you can put 0. Like this, they can be assigned here. X equal to 0, y equal to 0.
Okay.
Similarly, you can go with the other constructor, put like this here. Public point, then followed by here, you can put int x, then similarly int y, you can put here. Like this, you can take the parameters, then in the parameters, you can be setting it. What you write here, x equal to here, x, then similarly y equal to y, you can put like this. So using property methods, you can manage. So automatically inside the class, it is creating the required fields for us. So we don't explicitly declare any fields here. See, here apart from setting and getting, you can't do any other thing. But here there is a possibility of manipulating things. Further things also you can manipulate. Here return x you have written. Instead of returning x, you will put return x plus 10, x plus 20 also, something like that you can write here. You can manipulate things. As far as this particular thing is concerned here, we cannot do anything. You can just assign, you can just retrieve.
Okay. Yeah.
Suppose if I put here, if you put here return y plus 10, it can be returning that value or not. So programmer can manipulate to some extent here, but when you come to this kind of definition, even programmers cannot manipulate anything like that. Truly you are using for setting and getting. Since property methods are made for assigning values, retrieving values, for that purpose only you should use. But here what happens? You can manipulate things. You see, here return y you have, and y equal to value, you may be assigning some value, but if you put here value plus 10, what happens in such cases? The y value can be changing something. Whatever the user is giving, instead of giving user's value, something else can be taken there. But here there is no such possibility. Whatever value you give, that only will be assigned. So like this, you can have here automatic initializers of the fields. The field can be initialized automatically like this. This feature you find from the 3.5 onwards.
Okay.
Mahmood, understood this point? Sandeep, you have any questions on this?
No, not right now. Will later, but not right now.
Vincent, you have any questions on this? Okay. So here now I introduce a new concept called as delegates. We have a concept called as delegate. Delegate is basically something like callback functions in the C++ we have. Normally, using reference variables, you can refer data. Suppose you write like this. You put like this, string builder SB equal to, you put here new string builder. Now using SB, what you do, a string builder object is getting referred. Next time what you do, SB equal to, you may write here new string builder. With this, what is happening now? So initially when you made like this, an object called new string builder is created for us. It is available now. Next time what we do, we use same reference variable for pointing to another string builder object. There are two string builder objects available in the memory. With the help of first statement, you made the SB pointing to an object called string builder object. Okay. In the second case, what you do, you use same reference variable, but this time you can be pointing to some other string builder object. There are two string builder objects, string builder object 1, string builder object 2. Two objects are in the memory. With the help of the reference variable, what is happening? Initially, you have gone to string builder 1. In the second case, you are going to string builder 2. So with the help of SB, what you do? You are referring the locations. They contain what exactly? They contain data for us. Data as well as few operations you can perform on the given data. So using SB, you are referring those locations. In that location, you have the data as well as associate method loaded in that. Similarly with the SB also, with the second one also, what is happening? A new area is getting created. There you have the string builder object. With the help of SB, you can go to those locations and you can manipulate data. Like this is available for us. So these are referring actually data. SB is referring data. So SB is same here, but it can refer in the first case one object. It can be referring a different object in this. So like this, using same reference variable, you are referring different objects. Two different objects are referred with the help of the same name here. But as soon as you create the second object, you are losing reference to the first object here. Now this is what exactly? It's an orphan object we say. Orphan meaning is you have an object in the memory, but no one can use that. Even that we can call as a garbage. That can be called as even garbage. It is somewhere in the memory, but no one can use it because there is no reference to that. How to reach that object, we don't have a clue, we don't have an idea. So because of that, that becomes actually unreferenced objects, or we can say garbage, or we can say orphan object. We can use any of these words to describe it. Orphan object meaning is object is available in the memory, but no one can use because how to go there, how to reach the object, we don't have a clue, we don't have an idea. Same thing is here, we can call it as a garbage because the object is in the memory, but it's of no use. How can you use it? When you can reach, when you can do something with it, it is called as useful object. Otherwise, it's of no use. When it's of no use, it's nothing but garbage. So that is called as now a garbage object. Using SB, initially we created an object. With the help of SB, you could access that object, that's fine. But in the second case, what we have done, using same reference variable, you created another object. So what happens to previous object? Because the given reference variable can access at one time only one object. When you try to access another object, when you created another object and referred with the SB, you are losing reference for the first object. When you lose reference with the first object, it becomes therefore a garbage. It's called as garbage there, or it's called as orphan. So it is unreferenced objects. So such objects actually automatically garbage handled with the help of the .NET framework. They will be removed from memory because they are not useful objects. They are garbage objects. They don't have any significance. They are simply occupying memory. So such objects are of no use. Therefore, .NET framework is going to be removing them. It can remove such objects from memory. That is called as garbage collection. It can do here. So we have written string builder SB equal to new string builder. First of all, we create a string builder object. After some time, what we do, using same SB reference variable, we create another string builder object. We are going to create one more string builder object in this. So with the first, what happened? You referred to string builder. With the second one, you are referring another string builder object. So first object has lost reference. Now using reference variable, you are actually referring different data. So using save SB, you can be referring different objects at different times. But at one time, it can refer only one object. In the same way, with the help of delegates, you can be referring, in fact, different types of methods. A method can be referred with the help of the delegate. A delegate is similar to a function pointer. It is something similar to a function pointer in the C++. When you take C++, you have there actually function pointers or callback functions. Same thing here with the .NET. A delegate is nothing but a method referrer. With the help of delegate, you can be referring the methods. Delegates are implemented like classes only, but they can access a simple method. A method can be referred with the help of the delegate. So how we do the delegate C here? So in this, I can be defining a delegate. Here I can be defining a delegate. Okay, so before that, let me define some method within the class. In this class, I can be defining some static methods. Here write public, then static. This is int here, followed by add. This is nothing but a method I am defining. Then here int a, then int b. I have two properties, two data here. I want to return their sum here. Just put return a followed by plus b. Like this, we are going to be returning a plus b. This is exactly what I have defined a static method called as add. So it's a method. In the same way, I can be referring even subtract. Take here, then try to go with the subtract in this. We can go with the subtract in this. Here similarly, we go with the, multiply. Here in this, we multiply a with b. We are going to multiply a with b, and here we subtract b from a minus b, we write. So one is adding, one is subtracting, one is multiplying. Like this we are trying to do. We have defined therefore three methods: addition, subtraction, multiplication. We added here three methods. With add, we are adding two numbers. With subtract, we can subtract b from a. With multiply, we multiply a and b, we get the result. Like this, here we have written three methods. Now what I do, I can declare a delegate here. I can be declaring a delegate on the top of this one. Put like this. Delegate. This is followed by here. I want to put like this. Delegate name. I have to put here. Delegate name of the delegate. It is going to be my delegate. My delegate, it is int, then followed by, I can put here so I can be making like this. Int x, comma int y, like this. Okay. Declare like this. Int delegate. Okay, you can put 1 minute. Syntax I forgot, just going to be 25. Just delegate only we put here. Okay, this automatically should come. Fine, just let me see this. Syntax I forgot. Delegate declaration. Okay, this is only. We put like this: public delegate int. This is my delegate followed by int a, int b. Like this, we declare. We have created our own delegate in this public delegate int my delegate int a, int b. This way we created here. Now inside this main method, we can make this way my delegate. So delegate equal to new followed by my delegate followed by, here you can specify the method name. What is that method exactly? This can be called as here add method. Here we can put it as point.add. You can be referring like this method here. We are referring that particular method there. So now here write int sum equal to, we can be invoking like delegate dot invoke. You can be invoking it. You can pass the parameters here, something like 20, 30. You can pass like this. Then here in this system dot out dot println, we write like this sum. This way we can be printing it. Here write console dot read line. Console dot read line. We put like this. So with this, what is happening? Sorry. Console dot write line, and here in this it is sum. So my delegate equal to new my delegate point dot add. It is referring to point method. Here write int sum equal to delegate dot invoke 20, 30. You are passing two data 20 as well as 30. This can give you sum in this. So here first of all we are referring the add method. We can add, we can go with add method in this. Add method is getting invoked like this. Try to run this. You can find the result as 50 here. You are getting it as 50. We got this as actually 50. Now we created a delegate. With that we are referring the add method. Instead of using with points, we can indirectly access the add method here. We declared here a delegate. Delegate, as I told you, something like a class only, but this can be referring a single method. So it is going to refer a method here. We written like this. This is called as single cost delegate. Public delegate int my delegate int a int b. We are passing here two data, a as well as b. Okay, so this can be now calling any method which has this signature. The return type must be integer and the input must be integer and integer. So inputs must be integers and return type also integer. Such method it can call. If you come to the add method, The parameters are what here? Both are integers, and the return type is also integer. In the case of subtract also, what is happening? Both are integers, it can return integer. In the case of multiply also, you are passing two integers, it's returning integer. So like this here, we do with the help of the delegate here. Delegate, my delegate is a class, we defined here int a, int b, which is returning here integer data. Which is returning the integer data. My delegate is going to be your own delegate you created with the help of delegate keyword. Now using my delegate, you can be referring any methods which has same parameters, like the two parameters must be a integer and b also integer there. So integer types of data, two parameters, whatever method is supporting, and similarly if the method is returning integer value, so you can invoke that method with the help of the delegate indirectly. You created here a delegate, public delegate int my delegate int a, int b. So this is going to accept two parameters here, integer type of a and integer type b here, then followed by returning is also integer. So you need to pass two parameters, both of them must be integers, and return type also integer. So whatever methods have such signatures can be called with the help of my delegate. Whatever methods they may be, if they accept two parameters and if they are integer type and if they are returning integer type, such methods you can invoke with the help of the my delegate here. Using my delegate object, you can be invoking them. So for that purpose, we created my delegate delegate is equal to new my delegate point.add. You are calling which method? Point.add method we are calling in this. Now second one, after this, we make like this. Right here, my delegate, then another one also we put dg1 this equal to new my delegate here. Put like this, new my delegate. Then this is here point dot subtract. We can use point dot subtract. We do like this. Then here we can be finding. Then write int diff. We put diff equal to here right now dg1 dot invoke. We are invoking the method indirectly. We are invoking that method. We pass the parameters here 30, 20. So what should be result for us here? It should be 10 for us. It should print for us 10. So take this, try to print here the diff. You can put here diff. Try to execute this. What it's giving now? It's giving 10 for us because 30 minus 20 is going to be how much for us? 10. So like this we are finding the difference in this. In the second case we are finding difference. In the first case we are adding the sum. Both of they are exactly what delegate objects here. My delegate delegate equal to new my delegate point dot add. It is referring actually the add method. In the second case it is referring subtract method. So using this delegate now indirectly you are invoking the add method as well as subtract method. Seeing here, Mahmood, following these concepts here?
Yeah, yes, I'm following.
So first, using dgate, we are invoking the add method. With the help of dg1, we are invoking here subtract method. Sandeep, are you following this?
Yes, I have a question. I put it in a chat box. Is the concept behind delegate and enum is the same, similar?
No.
Be wrong.
Enum is different. Enum is actually data. Just you are declaring data with the enum. Constants you are defining. But this is what delegate. Delegate is nothing but a method referrer. You can refer different methods. If you come to the point class, you have methods like C. One is add method, one is subtract method, one is multiply method. Methods are part of what exactly point class. But using delegate, such methods you are invoking here. You are invoking those methods. How we have written my delegate delegate equal to new my delegate point dot add. But before that we declared here my delegate public using delegate keyword. We are declaring my delegate. This delegate is going to call a method. The method should be returning integer value and should accept here two integer data. It should accept here two integer parameters. So whatever methods they follow such convention, they are going to be getting invoked with the my delegate there. So public delegate int my delegate int a int b. So these are two parameters, integer parameters, and return type is what here again integer. So here if you look at these methods, add method, subtract method, multiply method, this they are taking two integer parameters, returning again integer data. In the case of subtract also they accept two integer parameters. They are returning integer. When you take multiply, they are accepting here two integer parameters, they are returning int data. So here what is happening? First of all, we declared a delegate. Delegate is accepting here two integer parameters, it's going to be returning integer data. So whatever methods they are referred with this delegate should accept these two integer parameters, should be returning for us integer data. So therefore, when you look at the add method requires what parameters? Integer parameter A, integer parameter B there, then it's going to be returning integer data. Same thing is happening in this. We are passing 20 and 30, then they are added, ultimately they are giving you sum, you get 50. In the case of second one, you are passing 30 and 20, the difference is how much? 10. 10 is getting returned here. So like this, we can be using delegates as pointer to methods. It is something like pointer to methods. That way, they are going to be working. So we again discuss tomorrow on this. Just try to go through delegates and events. Now we are coming into delegates and events. Events are going to be very important point in this. Even with the GUI, we use a lot with the events. What are events? How they are going to be useful? Try to understand. So events are a little bit advanced topic, but we have come to that stage now. We need to discuss about the delegates and events. So therefore, just try to focus on events as well as delegates. Just try to, lot of material is available. You can go through the material, you can find out, you try to understand what exactly the delegates and events are and what are multi-cast delegates. Try to just go through them. Then further we discuss tomorrow on the delegates. So further we can be discussing with the delegates tomorrow. So today what we have done, we created a library, then we attached a strong name with that. After that we have moved into GSE util. Okay, that part we completed. Even we can see that in the framework folder, .NET framework folder, we could see that we are seeing the library 2 times it is, 2 versions we got in that. But we should be using them in our application. That also we do tomorrow. Then similarly, further we discuss with the delegates as well as with the events. So delegates and events are very important. All these modern GUI applications or web applications, they are event driven. So they work with the events only, like mouse move event, click event, text input event like key press event, key down event. So those events, how they are manipulated, we need to understand. So that's why try to focus today on delegates as well as the events, how we can use delegates for events, how methods can be invoked with the help of delegate. Try to understand. This simple example I have shown you today. So tomorrow further we discuss with the delegates and events. Mansoor, understood this concept here?
Yes, please. Yeah.
So just try to.
I just like add on that. I not get your last lecture.
Yesterday I shared I think with you. Otherwise again I share. I'll be sharing today once again.
Oh, okay.
So you try to focus on these things also, events, delegates, and further we discuss tomorrow. We need to access the assembly which we put into GSE, Global Assembly Cache. That we should be accessing from our application. Tomorrow we see that part. But so far what you have done, just try to practice more and more on those. Try to revive those things, please.
Okay. Thank you.